thanks for stopping by my channel, The Math Nurse. If you would take a minute to like or subscribe to my channel, I'd really appreciate it. And today we're going to talk about an equation which will help with a lot of medical math and dosing calculations. That equation is desire over have times volume will equal your dose. All right. So another way to look at that is D over H, so your desire over what you have. So what are you desiring? What is the order for? What do you have on hand? And then what is your volume of what you have? And that will give you the dose that you're going to give your patient. All right, so for instance, we have an order for drug XYZ. The order is for 500 milligrams PRN for pain. So given as needed for pain. This could probably be something like acetaminophen or something. So what we have available is a 1,000 milligram tablet. And the question is, how many tablets will be given? So here's our tablet. It equals 1,000 milligrams. And your desire is 500. So this one's pretty straightforward, something you could probably do without math, without this calculation. But let's go ahead and plug it in so that you can see kind of step by step how to plug things in here. So we're going to put our desire, what we want to give the patient, what we desire to give the patient is 500 milligrams. What we have on hand is a 1,000 milligram tablet. We're going to times that by 1 basically because we have 1 tablet to give. That's our volume. That's going to give us 500 divided by 1,000, 0.5. Make sure you remember to do those leading zeros. 0.5 tablets is our answer. So we're going to cut that tablet in half and give it to the patient. All right, our second equation is drug XYZ. What the order is for is 10 milligrams given by mouth, PO, 2 times a day. The drug that we have on hand is a 5 milligrams in 5 milliliters. So we have our drug, maybe we got it out of the Pyxis or, from the med cart. And we have 5 milligrams for every 5 milliliters, there's 5 milligrams in that bottle. So if I were to draw up 5 milliliters for this patient, they would be getting 5 milligrams. All right, but we need to give our patient 10 milligrams. So we plug in 10 as our desire. It's what we want to give the patient. We're going to divide that by 5 milligrams. And then we're going to times it by 5 milliliters because that's our volume. And our answer is 10 milliliters. The next order we have is drug XYZ is going to be given to the patient. We want to give that patient 625 milligrams at bedtime. So that's our order. Available on hand, we have 250 milligrams in 5 milliliters. All right, so here's our little drug bottle, and it's labeled with 250 milligrams for every 5 milliliters. Again, when I draw up this syringe, if I have 5 milliliters in my syringe, that means the patient is getting 250 milligrams. All right, but we want to give our patient 625 milligrams. So we're going to take our desire, 625, divide it by what we have, 250, and we're going to times this one again by 5 because there's 250 milligrams in every 5 milliliters. So 5 milliliters is our volume. 625 divided by 250 times 5 equals 12.5 milliliters. That's how much we're going to draw up in our syringe to give the patient. 12.5 milliliters. The next equation is drug ABC. We're going to give the patient 60 milligrams IV daily. All right, so what we have available is 125 milligrams for every 10 milliliters. All right, so there's our RX bottle, 125 milligrams in 10 milliliters. So the previous examples have been given us something where we're doing more, right? Each of those had only 5 milliliters, and we needed to add more onto it. Okay, this one is going to be less. We're not going to give that full 10 milliliters because the patient only needs 60 milligrams. So we're not going to draw up a full 10 milliliters. So this is where this equation can come in very handy. All right, so let's go ahead and walk through it here. Our desire is 60 milligrams. That's what we're going to put in our syringe or in our medicine cup to give the patient. So our desire is 60. We're going to divide that by 125 and then times by the volume, which is 10 milliliters. And our answer will be 4.8 milliliters is what we're giving the patient. All right, so now we'll have orders sometimes where you have drug XYZ and the order is for 0.6 grams by mouth every 4 hours. However, the drug that we have on hand is 300 milligrams for every 10 milliliters. Okay, so we're going to have to do a little conversion here before we can actually approach the problem. So one thing you'll have to ask yourself is, what do you want the equation in? Do you want it in grams or do you want it in milligrams? For me, I like to switch the order to what I have on hand. So that's what we're going to do with this problem. So we have grams in our order, but I'm going to switch that to milligrams. Okay, because that's what I have on hand. That's what I physically have to give the patient. I have 300 milligrams for every 10 milliliters. Okay, so let's find out how much 0.6 grams is in milligrams. That's our very first step. So our desire is 0.6 grams. We need to convert that to milligrams, which is super simple. I've actually done a video on this about conversions if you'd like to go look that up, and it'll explain exactly what I'm doing here. We need to convert 0.6 grams to milligrams. So 0.6 times 1,000, that's going to give us 600 milligrams. That is now our order. Our desire is 600 milligrams because 0.6 grams equals 600 milligrams. So our desire that we're going to give the patient by mouth every 4 hours is 600 milligrams. That's how much we're going to put in our syringe. Okay, now the syringe doesn't necessarily have the needle on it when we give it to the patient by mouth, obviously, but we might have that needle on there when we actually draw it up, and then we'll give it to the patient without the needle by mouth. So we have our 600 milligrams. That's our desire. We switch that 0.6 to grams. 600 milligrams is our desire. We're going to divide that by 300 milligrams and then times by 10. That's going to give us 20 milliliters. We are going to give the patient 20 milliliters of drug XYZ by mouth every 4 hours. Let's go ahead and move on to the next question. So now our order is to give drug ABC 0.7 milligrams IV stat. So as soon as possible, we need to get 7.7 milligrams into our patient via IV. Okay, so the available drug that we have is 400 micrograms for every 1 milliliter. All right, so in our RX bottle, if we draw up 1 milliliter, that's going to give us 400 micrograms. Again, we have to do a conversion here. All right, so we've got 0.7 milligrams is what we need to give our patient, but we have 400 micrograms. So because we have micrograms, and that's what I'm physically going to give the patient, I'm going to convert my order to micrograms. So my desire is 0.7 milligrams. I need to convert 0.7 milligrams to micrograms. So I just take 0.7 and I times by 1,000. That's going to give me 700 micrograms. So my new desire is 700 micrograms because 0.7 milligrams equals 700 micrograms. I am going to give the patient 700 micrograms. So I take my desire, divide it by what I have, which is 400 micrograms, times it by 1, because I have 400 micrograms in 1 milliliter, and I'm giving the patient 1.75 milliliters. All right, so that is covering the equation desire over have times by volume equals the dose. If you have any questions, please feel free to reach out. You can DM me or leave a comment in the comment section below. If you'd like me to work through a problem that maybe you've encountered on the floor or in your career, please let me know, and I'd love to do that for you. If you have any other questions, also let me know, and don't forget to like and subscribe to my channel. Thanks for watching The Math Nurse.